Right now, as you watch this, the most dangerous, thermodynamically volatile atmospheric system in a generation is organizing over the heart of the United States. For decades, the veteran meteorologists staffing the National Weather Service and NOAA's National Hurricane Center have analyzed catastrophic inputs: Cat 5 hurricanes, 500-year floods, the worst super outbreaks. They are a professional class trained to use language with clinical measured precision. But in internal briefings within the last 6 hours, those men and women are using a word they almost never use publicly. A word that signals the complete failure of defensive infrastructure: unsurvivable. The models analyzed over the last 2 weeks have consistently pointed to this exact 48-hour window in April 2026, and the incoming real-time data now confirms the worst-case scenario. This is not a slow-developing crisis. The mechanics are accelerating. It is happening in real time. What scientists have seen in the last 12 hours of satellite data, radar imagery, and sensor network inputs from the Gulf of Mexico to the Rocky Mountains changes everything we thought we understood about the frequency and intensity of domestic natural disasters. The previous statistical baselines have been erased. We are not just looking at a major spring storm system that will dominate a news cycle.
We are about to witness 3 distinct, violently intense atmospheric engines, each powerful enough to disrupt a civilization on its own, converging simultaneously. The precise physics of this triple collision, this synoptic scale synergy, are without a functional precedent. These systems, a buckled amplified Arctic jet stream, an explosively deepening low-pressure bomb, and an anomalously extreme atmospheric river, are not simply going to pass near each other. They are meeting, they are coupling. The geometry of this collision zone is a verdict against the most densely populated severe weather corridor on Earth. My name is Daniel, and this is Natural Disasters. This is a geophysical autopsy of the immediate future. Let me explain the terrifying, precise mechanics that are shaping the atmosphere directly above you right now, because what is happening has no analog in modern American history. The chronology of this disaster is being written in millibars and degrees Celsius, and the ink is still wet. At 4:18 a.m. on April 14, 2026, a remote automated surface observing station near the summit of the Sangre de Cristo Mountains in southern Colorado recorded a central pressure drop of 1.4 millibars in a single hour. By 7:22 a.m., that rate of decay had accelerated across a network of sensors stretching from Santa Fe, New Mexico to Pueblo, Colorado. This is the unmistakable signature of explosive cyclogenesis, bombogenesis. In the jargon of the National Weather Service, a bomb cyclone requires a drop of 24 millibars in 24 hours. This system is currently on pace to shed 36 millibars in that same window. We are witnessing an atmospheric vacuum cleaner of unprecedented scale, a low-pressure core so deep it is physically warping the height of the tropopause above the American Southwest. To understand the geophysical violence of this moment, we have to look at the first atmospheric engine, the buckled jet stream. Normally, the polar jet stream acts as a fluid high-velocity barrier, a 250-mile-per-hour river of air that keeps the sub-freezing Arctic air masses locked in the north. But over the last 72 hours, the GOES-18 satellite has tracked a catastrophic Omega block failure. The jet stream has not just dipped, it has fractured. It has plunged southward in a jagged 2,000-mile trough that now reaches all the way to the outskirts of El Paso, Texas. This is a deeply negative tilt. It means the atmosphere is no longer flowing, it is churning. This southward plunge is dragging a massive, high-density reservoir of cold, dry air from the Canadian border directly into the path of the most humid air mass on the planet. This leads us to the second engine, the Gulf pump. Monitoring stations along the Louisiana and Texas coastlines are currently registering dew points in the upper 70s, readings more typical of the tropical Caribbean in mid-August than the American South in April.
Integrated water vapor transport (IVT values measured by NOAA's coastal sensor arrays are screaming. We are seeing a 750 kilograms per meter per second moisture flux. For context, the catastrophic 2017 floods in Houston were driven by EVT values of approximately 500. This is an atmospheric river of exceptional intensity, a Piney Woods Express that is funneling millions of tons of precipitable water northward at 60 miles per hour. This moisture isn't just sitting there. It is being violently sucked toward the Colorado low-pressure vacuum. The third engine is the lead. Meteorologists at the Storm Prediction Center in Norman, Oklahoma, are currently analyzing sounding data from weather balloons launched every 3 hours. They are looking for the capping inversion, a layer of warm air a few thousand feet up that prevents storms from firing too early. In a typical storm, the cap erodes slowly, letting off steam. But the data from the 10 a.m. launch at Will Rogers World Airport shows a cap that is being structurally compromised from below by extreme surface heating and from above by the approaching jet stream trough. The thermodynamic profile is beyond anything in our training manuals, says Dr. Elena Rodriguez, a senior research scientist at the National Severe Storms Laboratory. We are seeing CAPE, convective available potential energy, climbing toward 5,800 joules per kilogram in the warm sector over East Texas and Arkansas. At those levels, the atmosphere isn't just unstable, it's explosive. When that lead finally tears, the vertical velocity of these updrafts will exceed 150 miles per hour. These aren't just clouds, they are kinetic missiles. The tension in the monitoring rooms is palpable because the ground-based GNSS, Global Navigation Satellite System, stations are showing something else, a subtle but significant change in the friction of the boundary layer. As the low-pressure system deepens, the pressure gradient force is becoming so extreme that it is dragging surface winds from the southeast, while the jet stream screams from the southwest. This is vertical wind shear in its most lethal form. In the Tornado Alley corridor of 2026, the 0 to 6 kilometer shear is now clocking in at 85 knots. The threshold for a violent, long-track EF4 tornado is usually 60. We are at 85, and the sun is still rising. The infrastructure vulnerability here cannot be overstated. We are talking about a collision point situated directly over the I-35 and I-40 corridors, the logistical jugular veins of the United States. If the power grid in the Oklahoma-Texas-Arkansas triangle fails, under the weight of 100-mile-per-hour straight-line winds, the cooling systems for the region's massive data centers and medical hubs go dark. The United States Army Corps of Engineers is already monitoring levee stresses along the Arkansas River, where the soil moisture is at 98% saturation. There is no capacity left in the earth to absorb what is coming. The atmosphere has spent 2 weeks building a battery of unimaginable proportions, and the first sparks are already appearing on the radar over the Texas Panhandle. This is the moment the theoretical becomes physical. The clock hasn't just started ticking, it's about to explode. To understand why the atmosphere is currently behaving like a weapon of mass destruction, we have to look at the ghosts of the American landscape. History is the only yardstick we have for a system this anomalous. But the problem is that we are quickly running out of yardstick. Meteorologists at the Storm Prediction Center and the National Centers for Environmental Prediction are currently running analog searches, comparing current radar and satellite signatures to the worst disasters in the US archives. What they are finding is terrifying. Every single catastrophic event we've ever known is being eclipsed by the real-time data streaming in from the 2026 system. The first parallel everyone is whispering about is April 3, 1974, the original super outbreak. In just 18 hours, 148 tornadoes shredded 13 states. Xenia, Ohio, was nearly erased from the map.
That system was driven by a powerful mid-latitude cyclone, but it lacked the moisture transport we are seeing today. The 1974 event had a fraction of the precipitable water currently being measured over the Mississippi River Valley. Then there is the April 2011 outbreak, the gold standard for atmospheric violence in the modern era. Over 350 tornadoes in 3 days. The EF5 that leveled Joplin, Missouri, and the Lone Track monster that tore through Tuscaloosa and Birmingham, Alabama. In 2011, the wind shear was extreme, but the Cape values, the fuel, were 50% lower than what is currently building over the Ark-La-Tex region. But the most chilling comparison isn't a tornado outbreak at all. It's the 1993 storm of the century. That was a super bomb. A cyclone so vast it stretched from the Gulf Coast to the Maine border, shutting down every major airport on the eastern seaboard and killing over 300 people. The 1993 storm was a feat of synoptic scale, but it occurred in March, when the air was relatively dry. The April 2026 system is essentially the 1993 superbomb, but it has been injected with the tropical moisture of a Category 4 hurricane. Scientists call this system coupling. It's when the mechanical energy of the jet stream perfectly synchronizes with the thermal energy of the ocean. Usually, these two forces are out of phase. Right now, they are in a perfect lethal lockstep. We are looking at a 1,000-year event occurring in a 24-hour window, notes a lead hydrologist from the US Geological Survey. The statistics aren't just dry numbers. They represent the breaking point of American infrastructure. The current forecast models, the GFS and the European ECMWF, are showing a tight ensemble spread. In forecasting, a wide spread means uncertainty. A tight spread means the models agree on a catastrophe. They are projecting a mesoscale convective system, MCS, that isn't just a line of storms, but a self-sustaining atmospheric engine. The science of cyclicity tells us that the Great Plains and the Mississippi Basin are essentially a laboratory for this kind of violence. The unique geography of North America, the north-south orientation of the Rocky Mountains and the Appalachian Range, with a wide open corridor of flat land in between, is a funnel. It allows cold, dense air from the high plains to slide under the warm, buoyant air from the Gulf with zero topographic interference. This is why the US has more violent tornadoes than the rest of the planet combined. But the 2026 anomaly has pushed this funnel into a state of supersaturation. The US Army Corps of Engineers is particularly focused on the new tornado alley. The shift of peak intensity away from the sparsely populated plains of Kansas and Oklahoma toward the densely wooded high population zones of the Tennessee and Ohio River valleys. In the old tornado alley, you can see a storm coming from 20 miles away. In the Tennessee Valley, you are surrounded by hills and trees. You can't see the danger until it's on top of you. And because the 2026 system is moving at forward speeds of 70 to 80 miles per hour, the warning lead times are being slashed.
Even with the best Doppler radar networks in the world, the window of survival for a family in a mobile home in northern Alabama or rural Kentucky is shrinking to less than 5 minutes. The twist that has the NOAA experts in a state of shock is the prefrontal squall. Usually, you get one big line of storms. Today, the models show 3 distinct waves. The first wave saturates the ground and weakens structures. The second wave, the main event, delivers the violent tornadoes. And the third wave brings the training rainfall, inches of water falling per hour over the same devastated communities. It is a compounding disaster. We aren't just looking at wind. We are looking at the total hydrodynamic failure of a 6-state region. The historical records of the 1927 Great Mississippi Flood are being pulled from the archives because the projected river crests at Memphis and Vicksburg are reaching levels that suggest the levee systems, engineered in the 1950s, are about to face a load they were never designed to hold. This isn't just weather anymore. It is a geophysical reckoning. As the sun crosses the meridian on April 14, 2026, the atmospheric data ceases to be a mathematical abstraction and becomes a terrifying, physical reality for 22 million Americans. The transition from forecast to event
is marked not by a gradual shift, but by a sudden, violent rupture of the sky.
This is where the story stops being about millibars and begins being about names, neighborhoods, and the total failure of the systems we rely on to stay alive. In Memphis, Tennessee, the tension is a physical weight. At the FedEx Global Superhub, the logistical heartbeat of the United States, the decision is made at 2:15 p.m. to ground all operations. It is a move with no modern precedent outside of the 9/11 attacks. Hundreds of aircraft are diverted or grounded as the inflow jet of the storm system begins to scream across the tarmac. This single decision triggers a cascading failure in the American supply chain. Life-saving pharmaceuticals, critical microchips, and time-sensitive industrial components destined for all 50 states are suddenly frozen in place. The economic hemorrhage begins at an estimated $250 million per hour. But the real crisis is unfolding in the manufactured housing corridors of the Mid-South. In a mobile home community on the outskirts of Paducah, Kentucky, we find 34-year-old David Miller. David is a veteran of the 101st Airborne, a man who knows how to read a battlefield. As the sky turns a shade of deep sickly olivine, he realizes the shelter-in-place order is a death sentence for his family. His home, built to the hot standards of 2005, is designed to withstand 90-mile-per-hour winds. The radar-indicated rotation, moving toward his coordinates, is suggesting an EF4 vortex, with internal winds exceeding 175 miles per hour. David packs his wife and two daughters into their truck, fleeing toward a concrete bank vault 3 miles away. He is one of the lucky ones who has a destination. Thousands of others are trapped in what emergency managers call the kill zone, where the speed of the storm outpaces the speed of the human decision-making process. At 4:42 p.m., the Great Silence begins. This is the moment the American telecommunications infrastructure, the invisible web of fiber optics and cellular towers, begins to disintegrate. In central Arkansas, the first wave of 100-mile-per-hour straight-line winds, known as a derecho, begins snapping 100-foot steel transmission towers like toothpicks. When the towers go, the cell sites follow. For a 150-mile-wide swath of the heartland, the digital world simply vanishes. No weather alerts, no 911 access, no GPS. Families are plunged into a pre-industrial darkness while the most violent winds on the planet bear down on them. The power grid failure is catastrophic. In the control rooms of the Southwest Power Pool in Little Rock, engineers watch in horror as voltage sag ripples across the multi-state interconnector. The sheer volume of debris hitting transmission lines creates a cascading trip scenario. By 5:30 p.m., 6.2 million people are without power. This isn't just about lights going out. It's about the failure of the pumps that provide municipal water, the ventilators in rural hospitals running on dwindling backup diesel, and the cooling systems for the industrial chemical plants along the Mississippi River. We are practicing triage on a civilizational scale, says Dr. Sarah Jenkins, a trauma surgeon at a major hospital in Nashville. By 6 p.m., her facility is operating on emergency power, the windows boarded, as the first wave of survivors arrives. They aren't arriving in ambulances. They are arriving in the beds of pickup trucks, covered in the pulverized pink insulation and gray mud that are the hallmarks of a tornado's aftermath. The injuries are battlefield-grade, blunt force trauma, impalements from airborne debris, and the unique, devastating crushing injuries caused by collapsing structures. The agricultural loss is equally staggering. In the Golden Triangle of Mississippi and the wheat fields of Kansas, the ecological impact is a black swan event. The unprecedented hail core, frozen projectiles the size of softballs, is not just destroying the 2026 winter wheat crop, it is stripping the bark of trees and killing livestock in the thousands. Initial estimates from the US Department of Agriculture suggest a direct loss of $4.2 billion in a single afternoon. The topsoil erosion from the 10-inch training rainfall is so severe that the Arkansas River is turning a deep bloody red from the silt. By 8 p.m., the unsurvivable verdict is being realized. In towns like Mayfield, Kentucky, and Jonesboro, Arkansas, the damage is not structural, it is foundational. Entire city blocks have been swept clean to the slab. The asphalt has been scoured off the roads. Search and rescue teams from FEMA Task Force 1, moving in under the cover of a rain-soaked night, find that their maps no longer match the reality on the ground. Landmarks are gone, street signs are gone. The geography of home has been replaced by a chaotic wasteland of mangled steel and shattered timber. The logistical challenge of the second outbreak is now the primary focus. While rescuers pull survivors from the rubble of the first wave, the second atmospheric engine is igniting over the same coordinates. The survivors are being hit again, this time by life-threatening flash flooding. The emergency management framework of the United States is being stretched past its elastic limit. There are not enough helicopters, not enough high-water vehicles, and not enough body bags. The 2026 system has achieved what no foreign adversary ever could: the total tactical neutralization of a three-state region's ability to respond to its own destruction. When the sun finally rises over the American heartland on the morning after the April 2026 outbreak, the satellite imagery will reveal a landscape that has been structurally and ecologically redefined. But the true horror of this event isn't just the debris fields stretching from Oklahoma to Virginia. It is the realization that this was not a statistical fluke. This was a proof of concept. The atmosphere has provided a demonstration of its new capabilities, and the data suggests that the once-in-a-generation storm is now the baseline for the mid-21st century. As we look toward the 2027 and 2028 seasons, the risks are no longer confined to the traditional boundaries of Tornado Alley. We are seeing a permanent eastward migration of the most lethal convective environments. The new Tornado Alley is now firmly centered over the deep silty soils of the Mississippi Delta and the rolling hills of the Tennessee Valley. This geographic shift is catastrophic because it moves the bullseye into regions with higher population densities, more complex topography, and an aging infrastructure that was never designed for EF5 wind loads. The vulnerability of the American South is now the primary national security concern for FEMA and the Department of Homeland Security. Consider the Great Mississippi Choke Point. The 2026 storm system deposited enough silt and debris into the Mississippi and Arkansas river systems to fundamentally alter their navigable depths. For the port of New Orleans and the upstream hubs in Memphis and St. Louis, this represents an existential threat to the 600 million tons of cargo that move through these waters annually. If the U.S. Army Corps of Engineers cannot maintain these channels against increasingly frequent 1,000-year flood events, the American interior becomes an island, cut off from global grain and energy markets. The economic impact of a permanent disruption to the Mississippi trade corridor would dwarf the immediate damage of the 2026 outbreak, potentially triggering a long-term contraction of the domestic agricultural economy. The power grid remains the most fragile link in our survival chain. The C- rating given by the American Society of Civil Engineers is no longer a warning, it is an autopsy report. The 2026 event demonstrated that our transmission infrastructure, the backbone of our digital and physical lives, is a 20th century antique, fighting a 21st century war. In the coming years, we can expect rolling atmospheric blackouts to become a standard part of the spring and summer calendar. As the jet stream continues to buckle under the influence of Arctic amplification, the stability of the western and eastern interconnects will be tested by wind and thermal loads that exceed their engineering tolerances. We are moving toward a reality where grid-down scenarios last not for days, but for weeks, occurring during periods of extreme heat and humidity that the human body cannot withstand without mechanical cooling. The insurance industry is already responding to the data that the general public is still trying to process. We are approaching an insurance cliff in the American heartland. As the frequency of billion-dollar disasters triples, the cost of protecting a home in the Tennessee Valley or the Great Plains is becoming decoupled from the reality of middle-class incomes. Entire counties may soon become uninsurable, leading to a slow-motion migration of millions of people away from the most volatile atmospheric zones. This isn't a theory, it's a market reaction to physics. The engine behind all of this, the warming of the Arctic at 4 times the global rate, is not slowing down. The omega block patterns that drove the 2026 disaster are becoming more persistent. The jet stream is becoming lazier, creating stagnant, high-energy atmospheric pockets that allow storms to sit and train over the same communities for 48 or 72 hours at a time. The thermodynamic loading of the Gulf of Mexico is also reaching a tipping point. We are now seeing sea surface temperature anomalies that provide enough latent heat to fuel supercells even in the middle of winter. The storm season is no longer a season. It is a permanent condition of the American atmosphere. This is the inevitability we must face. The data doesn't care about our politics, our property lines, or our sense of normalcy. The atmosphere is merely balancing a massive energy equation, and the United States happens to be the primary theater for that calculation. We are living in a period of hypervolatility, where the gap between a clear blue sky and a civilizational threat is narrowing to a matter of hours. As the pressure begins to drop again over the Rockies in the months to follow, and the moisture begins its inevitable crawl northward from the Gulf, remember what you saw in April 2026. The infrastructure is brittle, the geography has shifted, the numbers have changed. We are no longer observing the weather, we are witnessing the restructuring of the North American environment. The only defense left is the data, and the data is telling us that the clock is not just ticking, it is screaming. Stay vigilant. Know your terrain, respect the physics, because the atmosphere is just getting started. This is Natural Disasters. I'm Daniel. Watch the sky.